All right, 3.15, part 2. We're starting with average rate of change, and Joshua's going to read because he's wonderful.
Yes, sir. In previous units, we learned about the average rate of change of a function in rectangular coordinates. In the polar coordinate system, we will find the average rate of change of r with respect to theta over a given interval of theta.
All right, so how should we think of average rate of change? Algebra slope, all right? And so now we're going in theta mode or polar mode. And so when we do this, our f of theta is our r. And so if we're going from A to B in terms of theta, a lot of times they'll use alpha to beta to denote the angle measures. But we just have f of B minus f of A over B minus A. So it's just like our algebra slope from before. But really, it's our change in r over change in theta. Because f of theta is our r. And so it's our change in r over change in theta. All right? And so geometrically, what do we got?
Geometrically, the average rate of change indicates the rate at which the radius is changing per radian.
All right, so that's really what's happening, is it's our rate per radian. All right, cool. And so in example 5, we have this function. And so we have 3 minus 3 cosine theta. What is that, first of all? It's not a circle. It's not a ball. What is that? So what kind of shape is that? It's a healthy button. So where's the bulk? To the left. Why is it to the left? It's a negative cosine. All right. And why is it a healthy? Why is it a regular old cardioid? Because A and B are equal. Beautiful. All right. And so what we're going to do is we're going to find the average rate of change of this function on the interval pi over 2 to pi. And so what we're going to do is we're going to find f of pi minus f of pi over 2 over pi minus pi over 2. Because an average rate of change is just what again? Algebra slope. Good. All right, and so now we're just going to substitute in pi. And so what is the cosine of pi? -1. So now -1 times -3 is 3. And so now I'd have 3 plus 3, which is 6. So f of pi is 6. Minus, now I'm going to substitute in pi over 2. So what's the cosine of pi over 2? 0. So then what do I get, Kefa? 3 minus 0, which is 3. Good. All right. And so then I get pi minus pi over 2. And so what do I think of pi as? 2 pi over 2. So 2 pi over 2 minus pi over 2 is how much? Pi over 2. And so now I have 6 minus 3, which is 3. 3 divided by pi over 2 is really multiplying by what? 2 over pi. And so then my average rate of change on the interval pi over 2 to pi is 6 over pi. And that is our average.
The figure shows the graph of the polar function r equals f of theta, where f of theta equals 3 sine 2 times theta. For 0 is less than or equal to theta, which is less than or equal to 2 pi. In the polar coordinate system, how much of the following intervals is the average rate of change of f of theta equals 0?
All right, so an average rate of change is equal to what? 0. And so what is an average rate of change again? It's just algebra slope. All right. When is the average rate of change equal to 0? So what is average rate of change again? It's the change in what? R over the change in theta. Well, how the heck do I get 0? What do I need my r's to be? The difference of my r has to be 0. So when do I get a difference being 0? The r's are the what? The same. And so this is when my radiuses are the same. All right. And so let's kind of substitute in each one to see what works. All right. So if I go from pi over 4 to 3 pi over 4, I need to find f of 3 pi over 4 first. So let's substitute in. So what's 2 times 3 pi over 4? 6 pi over 4. AKA what? 3 pi over 2. And so what is the sign of 3 pi over 2? -1. -1 times 3 is negative 3. So now I have negative 3 minus, now I substitute in pi over 4. So when I substitute in pi over 4 here, 2 times pi over 4 is pi over 2. So what's the sign of pi over 2? 1. And so 3 times 1 is 3. Do they cancel? No. So is it going to be equal to 0? No. So the average rate of change is not equal to 0. So let's look at part B now. And so now I'm going to substitute in what? 5 pi over 4. So let's do it. So when we substitute in 5 pi over 4, 2 times 5 pi over 4 is what? 10 pi over 4, which simplifies to 5 pi over 2. And what do I need to do? I need to use a period. And so what do I need to subtract? 2 pi, which is known as what? Pi over 2. So what is the sign of pi over 2? 1. So 1 times 3 is 3. And so now I'd have 3 minus, well, I substituted in 3 pi over 4, but what was that one? That was negative 3. And so is it going to cancel out? No. So my average rate of change is not equal to 0. So let's check out the next one. So now what do I substitute in? 7 pi over 4. So let's do it. So 2 times 7 pi over 4 is what? Okay, 14 pi over 4. That's fine. Simplify it. What do we get? 7 pi over 2. But that's not my unit circle. So what should I use? A period. So what's a period with 7 pi over 4? Or 7 pi over 2, I'm sorry. 3 pi over 2. All right. And so what's the sign of 3 pi over 2? Negative 1. Negative 1 times 3 is negative 3. So now I have negative 3 minus, now I substitute in 3 pi over 4. Well, we've done that a couple times. What do we get? Negative 3. Well, what happened on that one? They canceled out. So what is my average rate of change on that interval? 0. Now, I want to show you another way to Tampa. All right. This is a great method because in average rate of change, you find your difference of your y's over your difference of x's. In this case, your difference of r's over the difference of thetas. However, this is a sinusoidal curve. And so a lot of the times when we deal with these things, we can deal with our sinusoidal curve. But what's my normal period of sine? 2 pi. To get my period, I take 2 pi and divide it by what? My b. And what is my b in this case? 2. And so what's my period of this function? Just pi. And so now it's going to complete its cycle in pi. So everybody see how this is happening? And so where does sine start? Sine starts at 0. On this one, what is its amplitude? What's its amplitude? 3. And so which way does sine go? It starts going which way? Up. And so it wasn't flipped, so it's going to go up and then back down and then back up again. And its maximum's at 3, and so its minimum's going to be at what? Negative 3. Now, it crosses halfway in between my period, and so when's it going to cross? At pi over 2, right? And so a period is when it has a cycle. And so it's just going to cycle another pi. And so if I kept on going, it would do the same thing. And so when I'd cross the x-axis again, this would be at 3 pi over 2 because it's in the middle. So where is this maximum at? It's in the middle of 0 to pi over 2. So where's this maximum at? At pi over 4. Where's this minimum at? 3 pi over 4. And then this one would be what? 5 pi over 4. And this would be 7 pi over 4. Well, let's looky here. And so if I go from 3 pi over 4 to 7 pi over 4, that's really happening right here and right here. And an average rate of change is just what? Algebra slope. And so what's really happening graphically? My slope is what? 0. It's flat. It is 0. And so that's really what's happening, and you can easily see it on a sinusoidal curve rather than a polar function.
In the polar coordinate system, the graph of the polar function r equals f theta is shown with the domain of all real numbers, values of theta for 0 is less than or equal to theta, which is less than or equal to 2. On this interval of theta, the graph has no holes, passes through each point exactly one time, and as theta increases, the graph passes through the labeled points A, B, C, and D in that order, on which the following intervals is the average rate of change of r with respect to theta least.
All right, so an average rate of change being the least. All right. This is actually kind of important that it passes through A, B, C, and D in that order, because this tells me that my radius is not going to be negative. Does everybody follow what I just said there? All right, because it doesn't always have to be. It could be like there, and then there, and then there, and then there, or something. All right, if my radius is negative. All right. So anyway, so the average rate of change. What should I think of again? Algebra slope. All right. And so really, it's the change in r over the change in theta. And so let's kind of go through it without even doing much math at all. So what is my r-ish in A? What's my r? 3. I'd go 3. All right, cool. And so what's my radius in B? 3. All right. And so if I have a radius that's the same, well, what do we know my average rate of change is going to be? 0. And so this average rate of change from A to B is 0 because I didn't change my radius. It's still 3. So now let's go from B to C. And so what's my radius on B? 3-ish. Cool. What's my radius of C? 4-ish, 5-ish. I'd go more 5-ish if I were doing it. And so this is 5-ish. Okay, it's an ish. All right. And so what do we know happened? My r got what? Bigger. And so what do I know my average rate of change is going to do? It's going to increase. And so what do I have? It's positive. All right, so my average rate of change is positive on that one. All right, so now let's go from C to D. Well, what's my radius on C? Like 5-ish. What's my radius of D? 5-ish. So what's my average rate of change? 0-ish. All right, and so now let's go from D to A. And so then what's my radius on D? 5-ish. What's my radius of A? 3-ish. Well, what did it do? It decreased. And so my average rate of change is what? Negative. And so that is my least.
Estimating values of r equals f of theta using the average rate of change. For a given interval, we can use the average rate of change for r equals f of theta over the interval to estimate other values of r equals f of theta inside the given interval. Recall the point slope form of a line is given by y minus y1 equals m times x minus x1, where x1 y1 is a known point on the line and m is the slope of the line.
All right, beautiful. And so now we're going to go from that to f of thetas. All right, and so on f of thetas, my y is going to be our f of theta, and our slope is going to be what? An average rate of change. All right, so an average rate of change is what? Algebra slope. And so it's my y1 plus my slope, and then our x, basically our theta, minus where our theta is. All right, our input value. Okay, and so that's going to be our point slope form of a line. So let's go to example 8 now, Jackson.
The table above gives values of a polar function r equals f of theta as selected values of theta. Using the average rate of change of r equals f of theta over the interval pi over 6 is less than or equal to theta is less than or equal to 7 pi over 6 to approximate f of 5 pi over 6.
All right, so I need to go from an average rate of change on this interval, pi over 6 to 7 pi over 6, to approximate what? F of 5 pi over 6. All right. Now, I want to caution you on it a little bit. And so if they have like more stuff, like let's say they have 11 pi over 6, and let's say they have 2 pi, these kind of are distractors because 5 pi over 6 is in between those two. And so those are the two that I want to work with because that's going to give me my closest slope. Does everybody see how we're talking about it? All right. And so that's where we're going to approximate this f of 5 pi over 6. But the first thing we need to do is find our slope. So how do we find slope? F of 7 pi over 6 minus f of pi over 6 over 7 pi over 6 minus pi over 6. All right, so we're just finding slope right now. So what is f of 7 pi over 6? Tells you on your little chart. -1. And then minus, what is my f of pi over 6? 2. over, what is 7 pi over 6 minus pi over 6? 6 pi over 6, aka what, Asher? Pi. And so my slope here is what? Negative 3 over pi. And so that's our average rate of change. We'd end up with our line, y equals negative 3 over pi, times theta minus what? What value do we want to use? It doesn't really matter. And so, do you want to use that one or that one? Let's do the pi over 6 then. So now we have negative 3 over pi, and then theta minus pi over 6, and then plus f of pi over 6, which is known as what? 2. And so there is our equation. Now it says to approximate f of 5 pi over 6. And so this is the notation we need. We need f of 5 pi over 6 and then a squiggle. Why do we need a squiggle? Because it's an approximate, all right? And so in calculus, we need that little squiggle whenever it says the word approximate as well. So I need to get you used to it now, so later it will be even better. All right, and so now we're just going to substitute in what? 5 pi over 6. And so now we have negative 3 over pi. And then we have 5 pi over 6 minus pi over 6 plus 2. So what is 5 pi over 6 minus pi over 6? 4 pi over 6. What does 4 pi over 6 simplify to? 2 pi over 3. And so now we'd have this as 2 pi over 3, and then still plus 2. And so what happens with my negative 3 over pi and 2 pi over 3? Does anything cancel? The 3's cancel. What else cancels? The pi's cancel. So then what are we left with for this product? Negative 2. So now we have negative 2 plus 2, which is 0. And so 5 pi over 6 is about equal to 0.